Welcome to the fifth and final lesson in session 2 on problem solving. Problem solving with linear equations and inequalities involves identifying the variable, writing an equation, solving the equation, and finally checking the reasonableness of your answer. We're going to cover two examples. One is going to be that of an equation, and the second one is going to be that of an inequality. In our first example, we're analyzing the cost of two health clubs, trying to decide which one is going to be better for our membership. One health club charges a $50 sign-up fee and $65 per month, and another club charges a $90 sign-up fee and $45 per month. For what number of months is the cost of the clubs equal? For this, we're trying to figure out a breaking point. First step is to identify the variable, and we're going to identify the variable M to represent the number of months that we've joined each gym as we analyze the cost of each one. At some point, the cost of a club is going to take over and become more expensive than the other club, and we want to know after how many months that's going to occur. Next, we need to write an equation. So in this case, $50 plus 65 times M is equal to $90 plus 45 times M. 50 and 90 represent the sign-up fees, which is a constant value. 65 and 45 represent the coefficient of the variable, because that's how much we're paying per month. We're going to multiply 65 and 45 by the number of months for their respective clubs. Now, to solve the equation, we need to collect the variables on the same side, so we're going to choose to subtract 45M to both sides of the equation, leaving us with an equivalent equation of 50 plus 20M equals 90. Subtracting 50 from both sides gives me 20M equal to 40, and dividing both sides by 20 gives me a solution of 2. Now, after we solve, we always want to check the reasonableness of this answer. So at the beginning, I know that a negative number would not make any sense for this type of equation, because we wouldn't accept a negative number when you're dealing with units in time. Since we're dealing with months, a negative number of months would not be reasonable. For this answer, 2 months is a reasonable solution for this problem. In our second example, we're going to work with a conjunction. So the acidity of the water in a swimming pool is considered normal if the average of 3 pH readings is between 7.2 and 7.8 inclusive. The first two readings for the swimming pool are 7.4 and 7.9. What possible values for the third reading will make the average pH normal? So for the variable, we're going to select the variable P to represent the third pH reading. We already have the first two values of 7.4 and 7.9, and to find an average, we add all 3 pH readings together and divide it by 3. Now, that average has to be between and including 7.2 and 7.8 in order to produce a normal pH for the swimming pool. So the equation, or the inequality in this case, that we're going to produce is a conjunction beginning with 7.2 is less than or equal to the 3 pH readings, P plus 7.4 plus 7.9, all being divided by 3, so that's the average, since we're dividing by how many readings we have to take, and that's going to be less than or equal to 7.8. Notice we include less than or equal to signs due to the word inclusive. That indicates to us that 7.2 and 7.8 need to be included in the solution set. So to solve the inequality here, we're going to start by multiplying all 3 sides of the compound inequality by 3, giving us 21.6 is less than or equal to P plus 15.6, which is less than or equal to 23.4. Notice the 15.6 came from adding 7.4 and 7.9 together, as those were the first 2 readings. We wrap this up by subtracting 15.6 to both sides, and that gives us 6 is less than or equal to P, which is less than or equal to 7.8. That sounds like a very reasonable solution. Our pH reading needs to be between 6 and 7.8, including 6 and 7.8, in order to produce an average pH that is in the range of normal, meaning it's between 7.2 and 7.8. All right, that wraps up the 5th lesson as well as the session 2. So good luck on the quiz and good luck on the test.